Hello, everyone. My name is John Ryan, and the topic I'm presenting today is penetration testing. And it's a huge topic. I know it's the end of the day, so I'm going to move pretty quickly through it. And I'd propose if we do any questions at the end, I'll try and squeeze in as much as I can. So, penetration testing. First of all, about me, I trained in medicine originally. I've been a Fox user since the dark ages, and I am notoriously paranoid about security. So I guess it's appropriate that I should be the one presenting on penetration testing. So what I'd like to talk about is penetration testing, what it is, why it matters, a view of a pen test report, the different types of testing, some VFP context, the debugger. In the past, I've chosen not to show the debugger, but I'm going to today, and our organizers can decide whether they want to put that into the video. And if we have time, I'd like to revisit OAuth 2 as an easy way of passing some penetration testing tests. So the summary of the presentation is that watching out for vulnerabilities in your applications is good business. It protects your customer and you. And if you don't do some of the stuff I'm going to show you today, your customers can and eventually will. And it's embarrassing if there's easily resolved breaches that could have been fixed but haven't been. And as we go, it's important to distinguish implementation from design. That won't come as news to anyone, I'm sure, but as you'll see, not everybody in the pen testing world does that. I'd like to cover some easy VFP wins that should be done regardless, which will cover off multiple potential vulnerabilities. Many already do these things, but you just need to document them. And some free wins from VFPA and VFP compiler. All right, so what is it and why does it matter? So lots of different words for the same thing. And in essence, it's a subset of ethical hacking where the definition says a mock cyber attack, but it is in fact a cyber attack to try and find and exploit vulnerabilities so they can be remedied. It's more comprehensive than vulnerability assessment. Now, a vulnerability assessment is an automated scan looking for potential vulnerabilities. Pen testing adds to that by actually trying to exploit the flaw. So technically, pen testing should have fewer false positives, but if the pen tester can exploit it, then it goes up in severity because it means it's no longer potential or theoretical. It is in fact an exploit. Second reason to do it, it's recommended by cybersecurity experts, now including the government in more than one jurisdiction. Thirdly, compliance is coming in. Now, you'll hear about HIPAA and other privacy legislation pen testing. Those don't actually require pen testing, but the argument is you can't say that you're complying easily unless you can show that you are. And that third one is the compliance standard for receiving credit card payments. And to comply with that, you have to commit to performing pen testing. So it is coming. The pen test report, it all seems very complicated, but I think most people who use VFP are seasoned veterans, and none of this is particularly difficult or unfamiliar. But you need to start with an executive summary if you're going to produce a pen test report for your customers, because the management needs to be able to look at it and their eyes will glaze if it's too long. So 1 or 2 pages covering off the types of vulnerabilities that were detected and the consequences for the organization if they were to be exploited, and perhaps a summary of the recommendation section. You always want that at the start, summarizing your findings. There needs to be a recommendation remediation section. Short are the severe ones, medium and long term, you can wait till the next release, etc., etc. And theoretically, it's supposed to be based on a scoring system, and there are calculators available online. But most of what I'm seeing breaks things down into a number of big categories. And I think that's the direction that's going in. So you've got critical risks, high risks, medium risks, low risks, and informational. That's where it's going. Some of the automated scanners actually help with scoring if you need it. And most scanners help with identifying the particular risk and the recommendations. And yes, we are going to look at an automated scanner shortly. Need a technical findings section, like a peer-reviewed paper. What was the way you tried to utilize the breach? What were you trying to do? Was it to exfiltrate data? Was it to corrupt data, upload contagions? What was required in the breach? So that's whether you had a login or whether you were an external hacker trying to smash in, or whether you utilized source code, and the attack chains, which is the mechanism you used to confirm the breach. It's worth recording successful and unsuccessful hack chains, because if you can't make anything of a theoretical breach, it's not as important, but it's important to know. All right, so the process, there's multiple standards and recommended approaches out there. I'm going to talk a lot today about OWASP. That is how you pronounce it. We'll come back to it shortly. But basically, again, no surprise for most VFP developers, you scope what you need to do, you perform the work, and then you report afterwards. And there's lots of fancy sounding labels, but that is in effect what you need to do. If you pay somebody else to do it, brace yourself. What's happening, though, is that as the automated scanners become more and more capable, there's like a race to the bottom of cheap penetration testing, where you can get a pen test for as little as $4,000. The differentiator between a good pen test and a not good pen test is the amount of time spent trying to manually exploit the breach. And if there's no time spent exploiting, then you're paying money for someone to run an automated scan, put a little bit of verbiage around it, stick their logo on it, and charge you $4,000. So it's the attempt to exploit the scan that distinguishes pen testing. Usually people talk about this: black box testing, you're a hacker trying to smash in remotely. Grey box testing, you've got a login and some knowledge of the application. And white box testing, you've actually got the source code. So obviously much more capable testing as you step through those three areas. You've also got to distinguish web versus desktop, very different vulnerabilities. Desktop, you've got a big risk of decompilation attacks. A web you shouldn't have, but if it's misconfigured, you might have. But technically, the web is more likely to have more problems from things like cross-site scripting attacks and things that we're going to touch on shortly. Black box testing is less relevant for a desktop app. You don't really need to bash at it with no knowledge of the application. You've got access to the exe, and you might actually be able to access the source code from that. So VFP actually benefits from obscurity. Other more common languages have decompilers and even deobfuscators and quite good techniques to try and retrieve the source code. VFP doesn't have all of that, but just remember, Refox only costs a few $100s. And if you don't have a protected VFP application, that's all it costs to get your entire source code. And once you've got the source code, there's no protection from a hacker whatsoever. So what do we need to worry about? What should be tested? My recommendation is we look at the OWASP top 10. Now, I mentioned it earlier. OWASP until 2021 was the Open Web Application Security Project. In 21, it renamed itself, still OWASP, but now it's the Open Worldwide Application Security Project. And that was to signal the change from web-based security interest to desktop and now mobile security interest as well. And basically, OWASP is a collection of volunteering organizations and security experts producing resources, recommendations, tests, and really quite useful stuff to help everybody else secure their applications. So the top 10 are the most critical risks facing organizations, and a smart VFP person would focus on those top 10 and make sure that our work is reasonably protected from them. As I said, there are other standards, but OWASP is very widely regarded, and it's actually starting to be referenced in some of the regulatory requirements now. So I think as the expertise condenses, OWASP is likely to be one of the survivors, and it's a very suitable one for a VFP developer, as you'll see. So when you look at OWASP, anything to do with OWASP, if it doesn't say desktop or mobile, then its heritage is web and it's referring to web. So OWASP top 10 is the OWASP web top 10. Those are the top 10 risks in 2017. You can see starting with injection, moving through. 2021, injection demoted to third place, and now broken access controls number 1. And the next release is 2025, so literally months away now. So in the OWASP top 10, each of these risk categories has got a set of CWEs, common weakness enumerations, and the way of testing is to look at each CWE to see whether it's breached in the application, and if it is, then one or more of these risks is present in the application. Of interest, though, and it's an argument for pen testing, is that automated scanners can complete tests on only half of the OWASP CWEs. So there is a manual task required. So OWASP as of 21 includes top 10 desktop risks, similar but not the same. Injection still huge. Then comes broken authentication. Look at that number 3 there. I don't know whether you can read it. It's quite small, but data in memory after app logout. Does VFP leave data around after it closes down? Has anybody even thought about that? Well, the news is good, but we'll come back to that. So cryptography usage. So for example, you're using the VFP encryption.fll, but you're using encrypt and decrypt with using the default electronic codebook, ECB, which is insecure. And then the desktop's got more implementation type flaws. So we talked about you've got to distinguish them. Obviously, implementation matters more if you've got bad policies and things like that, then hackers can actually access more than they ought. Okay, and I've put this slide here just to make sure everyone is thinking, oh heck, at the end of a long day. Yes, this is huge, and OWASP itself is now recommending replacing level 1 pen testing reporting with a hybrid test, so it becomes at least grey, but more likely white box testing. And their justification, which they're recommending to governments all over the world, is that after 30 years of black box testing, exploits keep being missed and we're seeing more and more breaches. So they're really advocating white box testing, especially when you consider that automated scans can't even complete half of the CWE tests. So realistically, as VFP developers, we need to be looking at white box testing and not just running scanners against our applications and producing triumphant reports. All right, so just to give you an idea of the size of this, my initial plan was to step through all 10 of these risk categories, but it would take far more time than I've got. So that's a bad idea. I'll just focus on that first one. So this is the top OWASP top 10 report for 2021 for web, and 94% of apps needed to be tested for some form of broken access control. So that's almost all of them. So if we VFP developers can sort out that broken access control risk, then our apps can be better than the vast majority of apps out there. Except that 2025 is almost on us. And you can expect that we won't be the only ones focusing on this. So if we look at the CWEs that correspond to broken access control, that first one, CWE 200, in my opinion, that's hopelessly large and overgeneralized. So that includes everything from the ability to get the patient of another doctor through to the ability to pull up PHP files or information by delving where you shouldn't go. So there's multiple ways of meeting that one. And I suspect that in the 25 release, this will be deprecated and the focus will go on to the contributory CWEs that contribute to that number 200. 201 is big and is something we need to think about. So just as examples, if we're looking at a web app, say you've got a really smart application which is using Ajax and it's uploading JSON to the server. As I'm going to show you shortly, it's not difficult for a hacker to insert themselves between the application and the server. And if the hacker is able to lift your Ajax message and inject their own attribute, will your server application notice that? Or will it say, oh, well, it's come from my application and it only updates what it should, so we're going to allow that to happen? And same thing with a post, a form post. If the hacker is able to inject another field into the uploaded save, will your application know whether it's allowed to or whether that would require admin access? Or are you expecting your front end only to send back what is allowed? So something we need to think about. And this last one, cross-site request forgery, I'm going to cover that specifically in the VFP context, but that's basically a way of spoofing a logged in user's browser to do something unexpected. Probably not a huge realistic risk for our applications, but when it happens, it's devastating. Okay, so this is big. VFP, as always, has strategic deficits and advantages. So in the deficit side, I don't know whether you noticed, old, outdated components is in the top 10 in both 2017 and 21. And VFP is always going to fail that, not just in its own right, but because it uses the VFP 7 and 7.1 Microsoft runtimes, which are so old, they aren't even signed. So that's a problem. I have looked hard, but none of the accepted and recognized white box test suites can handle XBase code or VFP code. So that's a slight problem for us, but equally, some of the new major exploits just don't happen. It's not a problem. It's not going to happen. And normal VFP methodology provides fortuitous protection if you've used it. So remote views have often been maligned over the years, but if you've used parameterized remote views, then your work has been SQL injection proof since 1995. Okay, so talking about some of the scary risks we need to watch out for, this is an example. The deserialization hack. So the gist of it is, in the net world, if you use that Newtonsoft JSON.net to process uploaded JSON, then with certain settings, certain type name handling settings, if a hacker uploaded that JSON object, it will in fact run code on the server. And in this case, the code that it runs is the calculator. So when a net application used that JSON net to deserialize this, the calculator would start up. And that's done because some clever person understanding how that all works has been able to put something into place which tricks it into actually running the calculator. So if you can run a calculator, what else can you do? We're talking about causing code to run on the back-end server. So that's an example of the kind of scary stuff that's going on. And I've actually got a little piece of VFP code which uses the West Wind JSON deserializer, which uses the Newtonsoft library. And this hack does not affect VFP. I suspect it's because the Web Connect implementation of that library does not have the particular setting which creates a vulnerability, or it's possible that it's been fixed. But either way, it doesn't affect VFP. So that's the kind of thing that you see as you go along, where these huge, scary risks don't affect VFP. Okay, so what can VFP developers do? Well, first of all, black box testing of a web application is no different from any other backend. You're basically battering at it from without as a hacker trying to find your way in. It doesn't matter what the backend is. If anything, VFP's got advantages because a lot of the attempted cracks are utilizing potential weaknesses, particularly in things like PHP. So it's a waste of time with a VFP application. White box testing, we don't have an automated white box vulnerability scanner, but we do have tools like GoFish. Now, GoFish has got a lot of it. The most recent GoFish has got a really good search facility with patterns and things. So you can use GoFish, for example, if you're looking at the obsolete cryptography risk. You can go through quite easily looking for encrypt and decrypt from your VFP encryption.fll and make sure there's an extra parameter and it's not the default. So that's not so hard to go through, and of course GoFish searches the whole project. So you can be pretty confident once you've gone through and fixed them all, you can give yourself a tick. Same with SQL Select. Is it parameterized or concatenated? If it's all parameterized, you get the tick. And then next is all user entry escaped or sanitized to protect cross-site scripting. A little bit bigger. We'll come back to that. But the point I'm getting to is, I wonder whether GoFish can become a de facto white box tool for VFP. So in other words, GoFish gets another button or feature. When you click it, it utilizes its search capabilities against the project, and it runs through a set of tests and produces a report if it finds them or allows you to fix them, because of course you can fix code directly in GoFish. That's just something to think about as we go along. Okay, black box scanning. You used to say you've got to distinguish a network scan from a website scan, but that's becoming less important now for the simple reason, for example, that browsers expect HTTPS, and some browsers won't actually serve HTTP. So I think the chances of unencrypted material inadvertently traversing the network are becoming less and less. And what we're seeing is that automated scanners are beginning to incorporate capabilities from not just network and website scanning. Some of them can now do virus scanning or malware scanning. So the scan suites, to try and distinguish themselves, are gaining more and more features so that a lot of the stuff starts to merge in together. So I've put together a set of examples of the kind of black box tools available for VFP people. If we start probably Nessus, now hopefully this will come up in the browser. And the browser's in the wrong place, but I can bring it down. Right, so this is Nessus, and Nessus is nice and cheap. So for 1 year, it'll only cost you $4,588. But if you buy 3 years, it's only $13,000 and you've saved $688. Having said that, Nessus is regarded as a kind of a gold standard application. But just watch out. Those were the prices for Nessus Pro, and you need Nessus Expert if you want to do things like test the external attack surface and cloud infrastructure. And some of the available scans are only available for Nessus Expert, and the price is not published. But if we look at the product, now I've changed my resolution here, so I hope this doesn't become too unreadable. I'll just quickly show you what it looks like. Okay, I don't know how much that's showing up, but Nessus has got literally hundreds of available scans and features, as you would expect at that kind of a cost. So you maybe can't read it. Up from the top right is the basic network scan, but you can also do a cloud infrastructure scan. You can do a HIPAA scan. You can do a WannaCry ransomware scan. You can do Spectre and Meltdown tests for the leaked information. And there's all these different scans you can produce. So you can probably kind of imagine a security professional paying $4,000 and then proceeding to sell expensive scans to people. That's really the purpose of this. It would be an excellent choice for VFP people, but I don't think we need to pay $4,000. So the next option is OpenVAS or OpenVAS. So the history of Nessus, this first option, was when investors joined the company, it forked. An open source fork occurred, and OpenVAS came into being, or OpenVAS came into being. It is a classical open source application, and Nessus, as you'd expect from a $4,000 product, has advanced furiously in the GUI and presentation front, and OpenVAS is still a little bit open source looking. So you can run it on Windows, but you'll need a virtual machine to run the application. And the GUI is looking a bit old. Look, I'll try and bring this up, but it takes a long time to open. So I'll just bring it down so you can see it. Okay, I'll give it a few more seconds. Okay, so it's come up. So this is the OpenVAS website, and there is a community edition. What's happened is that this company, Greenbone, has kind of stepped in and become a curator, or sort of a custodian of the product, and it's gradually changing from OpenVAS into Greenbone. So it's now the Greenbone Community Edition. So there is a community edition. You can go in and utilize this, but I don't think it's the best option. Now I'll just change order slightly. OWASP, here they are again. So here's the OWASP 3 free application scanner. Now, I don't know whether it's going to happen or not. Okay, so this is interesting. Since I wrote this presentation last week, the OWASP Z attack proxy page has disappeared. If you search for Z, the page that comes up, and you click it, it takes you back there. So I don't know whether that means that ironically, someone's managed to hack this anti-hack site. Imagine the embarrassment, or whether it's a temporary mistake. But you can find the OWASP Zap itself is available from a Git repository, and you can install it on your machine, and it is free. I propose to show you OWASP Zap in a moment. Okay, carrying on. If you don't want to install OWASP Zap yourself on your own machine, there's sites like this where you get, if you've got an external facing website application, you can put a URL in here and it'll perform a scan, and there are free or community editions of this. Sorry, I'm just trying to, if we look down, there is a free version which lets you scan up to 3 targets once a month and produce summary reports. And that's probably okay for most VFP developers. So if that appeals, you can do that. Or next option is Burp Suite. So Burp Suite, very highly regarded. Possibly the best option for VFP, and it does have a free edition. So you can download and install a free edition, but if we just come down here, the free edition has got very limited functionality, and for example, you don't have the web vulnerability scanner, so you can't do an automated scan using the community suite. So not a lot of use. Having said that, if you decided to buy it, it is only $449 at the moment, but that's per annum. So that's not a bad option for VFP type people as well. And if we come back to my application, the consensus out there is that Burp Suite Pro, so that's not the community, that's the paid one, has got better automated scanning than OWASP Zap, but OWASP Zap is free. The other thing I would say is that in the last year, OWASP Zap has moved ahead in leaps and bounds. It is a really sophisticated application, and I think it's a very viable option for VFP. One thing to watch out for, it uses Java. So don't be me. There's 2 ways of installing Java. You can do it from a zip file, or you can do it from a Microsoft installer file. I've put a link here. The documentation says you need Java 11 or greater. My advice is to install the latest version 21 and do it using the MSI, because that puts in place all of the environment variables and other things that Zap needs. If you don't get that correct, Zap will keep saying to you, you need Java version 11 or later, and that gets very boring after a while. So just use the MSI, and hey presto, it'll work immediately. All right, so let's have a look at OWASP Zap. And now I'm going to need to be a little bit careful because I've just closed my system down. And what I'd like to do is bring in this remote desktop application. So this is a external PC that I'm running on, and I've installed OWASP Zap onto it. I'm just going to run it. So it is a Java application. It takes a little bit of time to initialize, but the good thing about Zap is although you have control over what's installed and everything else, it actually checks the plugins and extensions at startup and will in fact deinstall and install any updates. Okay, so this is the OWASP Zap user interface, and in the interest of time, I'm going to go through this really quickly. So there's a number of options. There's passive scanning and there's active scanning is the kind of the guts of utilization of this tool. If I go manual explore and say I choose southwestfox.net as a website that I would like to scan, what happens is that OWASP Zap brings up your default browser, navigates to the website, and although you can't see it, in behind the scenes, OWASP Zap has installed itself as a proxy server between the browser and the website, and it is analyzing everything and looking for potential breaches. And I'm sorry, the resolution on this thing is a little bit wrong, but if we look down the bottom, you can see that just on that first page, OWASP Zap is producing alerts. Now, apologies to our organizers. This is not intended to embarrass you. This is perfectly normal, but more to the point, as you can see, a lot of these risks that it's found are actually at the sites of people who should know better, not you. So if we look at the alerts that OWASP Zap has found on that first page, let's try and make a bit more room. Okay, so it's quite a few. You've got everything from cross-site security policy warnings that it doesn't like, mostly other people. Cross-site domain misconfigurations. It needs a anti-clickjacking header, a known vulnerable JavaScript library. That's Amazon. There's a cross-domain JavaScript source file inclusion. And then, of course, there's this annoying thing. To this day, some of the prevalent HTML renderers put X powered by and server into the HTML. It's not a good idea. That tells hackers what they need to focus on. It's better to let them guess. Although, if you're a VFP developer, perhaps you should put X powered by and put PHP or something in there so they can batter in fury attempting exploits that will never work. Okay, so that is and look, if we stepped through the site every step of the way, this is scanning and recording. Now, this is not hacking. This is legal. This is using passive scanning as you navigate the website. It's not altering the packets coming in or out. It's not attempting to inject payloads. So you're not doing anything wrong by this mechanism. All that's happening is that Zap is a proxy between you and the server. You can spider. I don't know whether you can read this. I'm sorry. This is quite hard to scale. I have tried. You can spider the site, and spidering is literally going through, following every link, every post, every submit, and it generates the list of all available resources at that site and gives you any errors that are on there. I won't spider this site because it goes all the way back to 2004, and finding everything, it takes a very long time. You can also do an AJAX spider. So if you've got a modern application that doesn't actually resubmit the form, but just updates the page utilizing asynchronous requests, the AJAX spider focuses in on that to look for weaknesses. And there's a whole lot of other things you can try. Authentication tester is quite useful. If you put in your login URL, username, and password, Zap will try and log in. It'll try and find the username and password fields. And if it can log in, then when you do your spidering or active tests, it'll actually log into the website so that you get more access to more stuff. That's grey box testing. Okay, so that's covering off maneuvering around the site yourself, passive spidering, passive AJAX spider. Then comes the active scan. If you run an active scan, you are attempting to hack the site. And if you do it without permission, either the site owner or their hosting agency will notice you and they will at least block you, but they also might try and track you down to identify you and report you. So don't be tempted to run an active scan against anybody else's site. The things that it does, it attempts SQL injection, it attempts code injection. It's doing really quite nasty stuff. So don't do it. If you do want to do it, the appropriate way to do it is what I've got here, which is sorry, I've just got to try and get this out of the way. This thing's expanded to cover the whole site. I can't see anything else. Okay. All right. Well, I've managed to snooker myself. This application has expanded the whole site, and it's not a modern interface, so it doesn't use normal Windows commands to shrink back down. I'll just exit. We can come back in easily enough. If you do want to run an active scan, get a Docker desktop on your site with your application and run it against that so that you're not interfering with anybody else. If I go back to my presentation, and this thing is determined to change. Okay, and I'll just go. So this is utilizing my own site. It generated 34,000 hits and 1,553 warning emails were generated after I closed down the firewall. You will be noticed, and if you have a look, it's actually trying some quite nasty hacks here. A misconfigured system may well allow it to reach that. So look, we haven't got time for me to give you any more on that, but download OWASP's app, install it yourself, put Java in the way I've said to you using the MSI, and you can experiment with the different settings. And it's actually quite good fun. And you'll be astonished what you'll find. Okay, white box scanning, I can't find any for VFP. So for VFP developers, independently of scanning your applications, there's a whole lot of easy wins. So first of all, you've obviously got to use HTTPS. You need SQL Server certificates. You've got to, at a minimum, encrypt your hits to and from the SQL Server. If you don't, that is a severe breach, and any scan is going to find it and you're going to get pinged. So if you haven't, it's not expensive these days to buy a certificate. It needs to be a specific type for SQL Server. If you buy the wrong type, you'll be buying another one. Can use self-signed. Don't use trust server certificate setting. I know a lot of us have been doing that, but that allows man-in-the-middle attacks. And as of ODBC driver 18, there's a new host name and certificate setting, which allows you to specify the certificate identification, so it doesn't need to match the server anymore. TLS 1.3 if you can. If you allow it to use 1.2 or perish the thought 1.1, any network scanner will pick that. Okay, digitally sign your apps. I'm not going to belabor it. It's like having no number plates in 2024 if you don't. In VFP, we have a problem. Unsigned dependencies. Everything from the Microsoft Visual C++ runtimes through to the sweet potato FLLs are unsigned. So maybe we can consider a VFP signing certificates and arrange centralized signing of some of these mutually shared resources so we can get past that. Easy wins. Use a framework. I can tell you for certain that some of the prevalent framework authors have been thinking and writing about securing websites for decades. So if you utilize their tool, they will have ways, it might even be default, that will include security settings for you and cookies and stuff like that. And no talk by me is complete without this one. Consider Visual Fox Pro C++ compiler and or VFPA. Number of easy wins, data execution prevention. Not available in VFP9. It's on by default in 64-bit VFPA and can be turned on with a sys setting in 32-bit. And that prevents a hacker dropping code into the middle of your data block and then spoofing the stack or patching in order to cause that code to run. Also, you can compile with a newer Visual C++. So VFP C++ compiler, the 64-bit is the minimum VC++ 10, which is a signed repository, or you can go all the way up to the latest 14. But if you're using FLLs except for Fox tools, because Schwabing Chen has recompiled Fox tools up to the newer versions, you still have that Visual C++ 7 dependency. Okay, briefly, in the old days, a lot of us enjoyed VFP's ability to generate very clear and explicit log files with all the variables in their contents, a few lines of code to bring up all the open tables and the current record in each of those. But it is not hard for a hacker to pull out a network port when your login dialog is exposed and provoke an error, which then gives them your SQL Server connection string. So we need to look very carefully at what's included in our log files. Maybe we need to release the types of variables that we know might contain important information, or maybe we need to rename our secure variables to names like S underscore, and then you can do a release all like S underscore in your error log handler. I won't go on with that, but of course the other obvious option is to encrypt or obfuscate the log file. So even if they do generate an error log, it doesn't matter. And I think the days when we had to worry about out-of-memory errors, which would cause another error if you tried to encrypt, are past us. So just look at your error logs. SQL injection, we all know well, with apologies to Rick Strowl if he's watching. If you go to the Westwind website and look at his guest book, somebody, not me, but somebody has been trying a SQL injection attack. That string you can see down the bottom there, that is an attempted SQL injection. And if we look at it, so this is the live site. If I go add guest, it's still there. So we're just running out of time, but let's have a look at this briefly. The way it works is if the application is concatenating SQL, then concatenating that string into a SQL select now looks for the rows where user ID equals the string -1 or this algebra, which condenses down to 1 equals 1. So the select will pull the entire table. And depending what's done with it, that can then be exfiltrated or whatever it might be. You might ask why it's so complicated. And the reason it's complicated is to spoof any input sanitizers. Other tools habitually use concatenation for SQL select. They have to sanitize their input. And this is a way of trying to hide the fact that you're producing an always true parameter. In VFP, we don't need to input sanitize. We can use parameterized queries, and you can use GoFish to go through and make sure they are. All right. This is big in VFP as in every other language. If a hacker, characteristically by entering a malicious payload into a user entry field, if they can display that in the browser of another user, they can cause code to run and may be able to do quite a few things. So that there in the middle is the standard example of somebody enters that into a description field for something, and then if your page renders that input without sanitizing it, they will get an alert box saying XXS on any other user's browser when they run this. So Microsoft says the majority of cross-site script attacks are targeting the cookie. So if you use Web Connect some time back, it introduced a new www cookie class. You can put an HTTP only tag in, which means it's not available anymore to scripts. And there's some other settings you can put, same site and secure. I'm going to move quickly past those because they're less important. Just watch out for them. That's the definition of a third-party cookie, and some browsers like Chrome are proposing to do away with them because it makes it too easy to track people across sites. So check your use of that nomenclature. And of course, hackers can count. Make sure it's a random cookie you're using, because if it looks like a incrementing integer, a hacker can try that and see if they can masquerade as somebody else. There's an XST attack, much less important. So for VFPers, the way to prevent cross-site scripting attacks from text input is to sanitize those 5 lines of code. Will sanitize user input to prevent a cross-site scripting attack. Good approach. Use GoFish to search all through your rendering. Make sure every user entry is sanitized. In Web Connect, it utilizes this convention here using a colon as opposed to an equals. That's actually an ASP.NET convention, and that causes HTML encoding in ASP.NET, and also in Web Connect, it wraps it in an encode HTML function for you. So that's quite an easy way of sanitizing. Okay, be careful though. That doesn't protect you if you're utilizing the content in JavaScript or parameters and things. It will in fact still run in JavaScript, because an escaped HTML encoded string in JavaScript will run regardless of the fact that you've HTML encoded it. You need to think about JS escaping conventions if you're utilizing it into JavaScript. Less common in VFP, but watch out for it. Much bigger problem if you've got users able to enter HTML. So Quill is the example. I haven't really got time. I'm running a bit behind here. Quill can generate HTML, which can be saved and then rendered. Very hard to sanitize HTML. Best advice is don't do it yourself. Don't use old, non-maintained sanitizers. In the Windows world, HTML sanitizer is probably your best bet. And utilizing something like .NET Bridge, you can sanitize your HTML using that. I'm going to move quickly past this. You can come back and have a look at it. It's to do with access control, allow origin. It's expedient always to put the star in there, but that creates a risk that a hacker can exfiltrate data. So if you can, limit the allowed origins. Just be aware that you saw just before OWASP was working as a proxy server between the browser and your application. You can actually stop OWASP or Burp Suite or whatever, and you can actually mess with these headers. So even if you did have a safe header, that can be messed with to allow it to function in the browser. So come back and have a look at this. Cross-site request forgery. The gist of it is you need anything that changes state on the server, you really should be including a CSRF token so that a hacker is not able to trick your site into believing that the user has raised this submission. because the external hacker won't have the CSRF tag, also pronounced CSRF. And a good way to do it is actually to include your CSRF token in with your form as a hidden input, or you can put it into as a header in the page, a custom header. I use the post because then I can make sure it's always present only where I want it. Whereas if you put it into the header and a get is raised, technically a hacker might be able to spoof acquisition of the CSRF. So that's just an example of how using Web Connect, you could embed your CSRF token in as a header. And there's another example of how you can do it just as a hidden input inside your form. Okay, desktop, the last 5 minutes, but that's okay. Quick security quiz. Once your app has got blocks of memory, nothing else can mess with it until your app releases it. Is that always true? Only true after Windows Server 2014? True since Windows 2000, or never true? The answer is it's never true. Any app in your same session can access your data and vice versa. If an executable is signed, Windows won't run it if a hacker has messed with it because the signature is invalid. Is that true or false? It's false. Windows will run it. It'll give you the yellow UAC warning, but it'll run it. A hacker can alter data memory, but not program memory for your application. Is that true after Windows 7 or 2014? Always true, or is it false? Memory is just memory. False. All memory can be edited. Okay, you can edit your application memory, but the operating system DLLs are inviolate. They're in protected memory. Hacker can't mess with those. Is that true? Is that true unless you have admin proofs? Or is it false? Anybody can mess with OS operating system resources and memory. False. Patching and hooking Windows functions are standard debugger techniques. Windows is insecure by design. Well, that's why they say it. It's as if it was expected that billions of Windows PCs are going to be used to debug machine code. There's even a processor int3 on every Wintel machine ever produced, which is a hardware breakpoint which stops execution and throws it through to the debugger. So to protect yourself from a debugger, Windows does provide functionality, except that the functionality is easily patched or hooked. And we're almost out of time, but I propose to show you that, if I can figure out how to present a view. So I did have a, I'll just run it on my own machine. So just give me a moment. Sorry, this is playing up a little bit. For some reason, this has gone right back, but we can just go through here. Okay, so what can you do to thwart hacking of your desktop application and preventing being debugged? Okay, VFP C++ compiler obfuscates your code. It allows you to compile it with newer versions of Visual C++, and it's got inbuilt detections for the debugger. There's 10 of them, and with a VFP, with a directive for the compiler, it will inject those into your code, and they're actually inlined directly into the code, which means that a hacker that wants to go through and knock them out. Knopping means that you utilize the debugger to put zeros there, doesn't do anything, has to go through the entire application to find them all. So that's certainly worth considering. Just for what it's worth, I've been doing quite a lot of work on this myself. I've come up with some stuff that I intend to share with Shrubing Chen. He might want to include that in future releases of VFP C++ compiler. I'm paranoid about this stuff. I've come up with some stuff which is fearfully difficult to anti-hack without a full decompilation of a giant C++ DLL. It actually uses deliberate error cascades to break a debugger attempt to follow your code. And that's just mean. It can still be hacked, but it's not worth it. And then don't forget, authentication rolling your own is really vulnerable, because if a hacker can pull the source code or stop the performance at a vulnerable point, they can simply lift important information. Windows insecure by design. So for the desktop, your biggest threat is decompilation. In VFP, there is a specific risk of hooking from memory. It doesn't matter how you protect your VFP app. If a hacker can cause VFP code to run inside your application by whatever means, they can hook the application from memory and they have access to your source code. So again, that's an argument for VFP-A, because standard decompilers like Refox don't decompile VFP-A. You could make it, but they don't. But also VFP encryption moves most of your VFP compiler moves most of your functionality into a C++. So who cares if they hook your VFP application? Good luck with that. The biggest threat number 2 for VFP is actually code injection. Standalone reports, DBCs, and any other entity with events makes it possible to inject code into your application. And if, for example, that code brings up a Fox console instance, the hacker can browse your entire system and perform any sort of mischief. Look at your, perform SQL queries using your connection. There's lots of stuff they can do. So we're almost out of time, but in my my collection of files for this presentation, there's a little file there on something you can do that makes a standalone report. It kind of brands it. And so before you run it, you can run a function which checks to make sure no one's messed with it. And that makes it safe to have standalone reports again. Have a look at it. So we are out of time. Thank you very much. This was a huge topic. Hopefully I've showed you some interesting stuff so you can go away and have a play with OWASP Zap. Do it yourself before somebody else does. And the debugger, I think the organizers can decide whether they want to include that in the video. Perhaps VFP's opacity is valuable enough that it's not worth putting it in, but that's how easy it is to hack a VFP application. And that's me. We are out of time, but does anybody have any questions?
We didn't have any questions at this time, but people are welcome to talk with you in the Q&A session after.
Okay. I might have to, if we go offline, if you can tell me how to fire up the Q&A session so I don't disappear into the wilderness, that'd be awesome.
Yep, I'll be in a second. Thanks.
Okay, right.